about FM generation. Okay, we have seen theory so far. You all know about it, right? We have seen bandwidth, we have seen the equations, we have seen the spectrum, right? Everything we have seen. Now, today we'll see how to generate an FM wave. That means what is the circuit required to generate an FM wave, right? Okay, let us go back to our basic principle of FM, right? If you see the basic principle behind FM, what exactly you are doing, tell me, in FM? Your frequency of the carrier wave, right? Or you can say instantaneous frequency of the carrier wave, instantaneous frequency, we are making it proportional to the message signal m of t, right? So something you are going to generate a frequency, nothing but oscillations. You're going to generate oscillations, which is the carrier frequency, which is the carrier wave, okay, whose frequency is proportional to m of t, right? And this m of t is instantaneous value of the message signal. This is proportional to instantaneous value of the message signal. So your frequency of a waveform, right, is now proportional to the message signal. That's what your FM is. Now, how do you generate this? There are two ways of generating an FM wave. FM wave can be generated using two methods. There are two ways of generation of FM wave. One is called as direct method, another one is called as indirect method. One is direct method, and one is called as indirect method. In direct method, first one, what we do, we will directly, okay, generate a wide band frequency modulated wave. Directly we will generate wide band frequency modulated wave. Hope all of you remember what is narrow band frequency modulated wave and what is wide band frequency modulated wave, right? So what we are generating is wide band frequency modulated wave. That is what your FM wave is. Narrow band frequency modulation is not an actual FM. You know, that is equivalent to your AM. I have explained you this in my previous class, right? Okay, so what we are going to generate is wide band frequency modulated, where your beta value is very, very high compared to 1. Now, in direct method, what we do, we'll have our system which will directly convert, okay, your message signal variation to frequency variation. The direct generation of frequency modulated wave, okay. Now, I told you that in direct method, you directly convert your, your message signal into wideband frequency modulation only. That's why it's called direct. Then what is indirect? Right, what is indirect? Indirect is something very, you use your existing hardware, right, of AM, and then use frequency multipliers to get wideband frequency modulator. So what is done in indirect method? First you generate narrow band frequency modulation wave. First you generate narrow band frequency modulated wave. After that you use something called multipliers to get your wide band frequency modulator. Now have you understood the difference? Right? So in indirect method, from where we start with the narrow band. But you have to generate wide band only. Right? What to do? How to do? You use in between multipliers. What you call it as a frequency multipliers. We start from beta less than 1 and we use multipliers, frequency multipliers in between, then we end with beta very high compared to 1 and desired frequency of your FM wave. So have you understood these two methods? In one method, directly we get wideband frequency modulated wave. In another method, we start from narrowband frequency modulated wave, then we use frequency multipliers and then get your wideband frequency modulated wave. We are going to study all these things. Have you understood this? Okay. So these are the ways you generate FM. Let us come to the direct one now. Let us come to the direct one. So as I told you, direct one is you directly generate wideband frequency modulator. It's something like you convert your voltage to frequency. So here, as I told you, that we use variable frequency oscillators. I'm going to give an assignment now, one hardware assignment, okay, which is actually generation of a waveform, right, which is not there for your lab, but as a part of your assignment, each and every student will be going to use a breadboard, and we'll give you components, okay, and you are supposed to build the circuit and show the output, which is a oscillation, which is a pure oscillation, okay, of desired frequency, right? So 18 students will be using 18 frequencies, right? I will tell you the design, how to design it, and then I'll give the circuit, and you will be given frequency, you will be allotted frequency, and you are supposed to generate an oscillator of, okay, that particular frequency. Have you understood this? Okay, it's simple. If you do, it is not more than 1 or 2 hours work, okay, maximum, okay. You just have to build a circuit on the breadboard, okay, according to the design, and get the things done. Okay, oscillator, because oscillator is something which you are not studied in microelectronics, and you're not going to study even in analog electronics also, I don't think. But that's why I want to bring in this concept of oscillators. Oscillators is something which will generate a waveform. There are lots of oscillator circuits available in the literature, okay. One of them can be active oscillator, which makes use of transistors. It's simple transistor feedback circuit, nothing else. You studied about feedback circuit, right, in microelectronics? Yes or no? Most of the circuits are nothing but feedback circuit only for you, right? So it is simple feedback circuit where you generate an oscillations using oscillator, right? So now in this context, in frequency modulation generation context, here you're going to generate oscillations, right? And that oscillations are varying according to the input voltage, that is called as variable frequency oscillator. We call it as VFO, variable frequency oscillator. A oscillator can generate an oscillation which is a constant oscillation. If I design an oscillator to generate 10 kilohertz sine wave, okay, it will generate 10 kilohertz sine wave continuously. Such oscillators are not called as variable frequency oscillators. Those are called as fixed frequency oscillator. But variable frequency oscillators are those which will generate variable frequency. waveforms. Now, we are going to make use of such oscillators in generating our FM wave, because FM wave requires something which generates variable frequency, right? And for which that variable frequency depends on message signal, instantaneous amplitude of the message signal, right? So if an oscillator generates an oscillation whose frequency is proportional to the instantaneous value of the message signal, that's all, that's enough for us to generate an FM wave. So we use such circuit, right? So now, before that, I want to tell you about fundamentals of this oscillator. Fundamentals of oscillator. How do we generate oscillations? Have you come across with the tank circuit? What is called tank circuit? Tank circuit. Tank circuit. Have you come across with a concept of tank circuit? Can anybody tell me about tank circuit? Microelectronics. Have you not come across with tank circuit? LC circuit, RC circuit, this is called tank circuit. LC circuit is called tank circuit. LC, electrical people. LC circuit. You in motor you have capacitor and your inductor, right? It is generating, certain sort of torque, yes or no? LC circuit, you forgotten. Being an electrical engineer, electronics engineer, never forget this LC circuit. This is the one which generates oscillation. So there will be, no, it is just nothing but your inductor and capacitor and inductor in parallel. That's all. So the moment you just charge this capacitor, okay, and it will discharge to this, right, to inductor, and inductor will once again charge capacitor, and this charge and discharge action will continue in this tank circuit. Have you understood about tank circuit now? Tank circuit is something which generates sustained oscillations. How it generates? Suppose if you just charge this capacitor, it will discharge to this inductor, and what this inductor will do? It will once again charge the capacitor inside that, right? And once again, what the capacitor will do? It will discharge through the inductor. So this process will continue, charging and discharging process will continue. And what it generates in the process of charging and discharge? Come on. See, charge, discharge. See, charge, discharge, charge, discharge, charge, discharge. What will continue? What it will generate? It will generate an oscillation. Right? So something called damped oscillation, undamped oscillations. Have you come across with? So LC circuit which is called a tank circuit, which generates oscillation, which is called oscillator. This is the simplest circuit which generates oscillations. Have you understood how does it generate oscillation? See, it's quite straightforward, right? Pure physics. Capacitor is charged, leave it. You charge the capacitor and leave it. The capacitor will discharge to the inductor. Inductor will once again charge the capacitor. Right. So this charge and discharge will continue until you have the enough energy in that. A simple tank circuit will generate an oscillation like this. After that, it will just lose its energy. If you want to make it sustained oscillation, you give feedback. You give one feedback circuit. You use a transistor and feedback circuit, which will generate a continuous waveform from this tank circuit. And this tank circuit is actually basic building block of your oscillator, which will generate oscillations. And why do we need to generate oscillations here? Tell me. To generate carrier signal, right? From where carrier signal will come? To generate carrier signal, we need oscillator, that's all. And we use the tank circuit to generate oscillations. Right, have you understood this now? Now, how do you make this oscillator to produce variable frequency? Right, variable frequency. That means, see, remember, these concepts are very important for you. Knowledge purpose is very important. I told you that you have a capacitor and an inductor, okay, L and C. This will produce oscillations. And how it produces oscillations, just now I have told you. Right. Now, this L and C is fixed now. This L and C are fixed value. It is fixed value. It is fixed value. When this L and C are fixed, it will generate oscillations of fixed frequency, one frequency. Right. Okay. So it will generate frequency will be fixed. Your frequency will be fixed. Now, how can I vary the frequency now? If I want to vary, I told you. How can I vary the frequency now? If I want to vary the frequency, change either C value or L value, right? Yes or no? Change either C value or L value. So I get variable frequency. Now how can I convert this tank circuit to behave like a FM modulated wave? What I should do? What I should do with this L or C value? Come on, tell me. Think about it. If you understood the concept, I told you that if L and C values are constant, it is going to produce fixed frequency oscillation. Right. That means if you want variable frequency, you have to change the value of either C or L. Yes or no? Right. Now, what I should do to use this circuit as an FM modulator? Come on, answer my question. I have only L and C, my dear. Where resistor comes here? No. Just think. Your frequency will change only because of either C value or L value. Right. You can make the variable frequency. You can make different frequencies oscillations by different values of C and L. Or C or L. Either keep L constant or change C. Or keep C constant, change L. Something you need to change. Right. Now, my question is, if I want to use this for FM generation, what I can do? What alteration I can do to this? Come on, think about it. You have two values to be varied, either C or L, to have various frequency. And you know that various frequency depends on what? Message signal. Now you tell me the answer. Think. Give enough time, enough work for your brain. What I should do? Tell me. Have you understood my question, right? To get a variable frequency, something you have to do with C and L. You know that, right? Right. Now, how can I use this as an FM modulator? What I should do with C or L to get variable frequency for FM, for frequency modulation? Come on. I want one answer, one intelligent, any one, please. Anyone, can you just, if you understood my question, I will repeat the question again and again if you have not understood the question. Very simple answer. I had told everything. Anyone? Anyone? Can you tell me? You all know when L and C is fixed, it's fixed frequency, right? You all know now, if I change either C or L, we get different frequency, right? Just your answer lies in this one sentence that if you change C or L, frequency will change. Now what should be this either C or L proportional to get various frequency in frequency modulation? Exactly, that's what I wanted. If you make this capacitor value, capacitance value, if I make this capacitance value proportional to the message signal, what will happen? Tell me. You will have various oscillations according to the instantaneous value of the message signal. That's what it does. So now I have to make this capacitance value to vary according to the input message signal. Have you understood? So which is that capacitor which will give you various capacitance, okay, according to the voltage given to the input? Which is that diode? There is one diode where output capacitance will vary according to the input voltage. Which is that? And that diode is called as varactor diode. Varactor diode. Have you studied this in electronic devices? Have you studied this varactor diode in electronic devices? That's why I said these engineering fundamentals, if you are perfect, anybody will give a job, right? And what this varactor diode will do? What is the property of this varactor diode? This varactor diode, it is something like voltage to capacitance. Input is voltage variation, output is going to be capacitance variation. The capacitance of the varactor diode will vary according to the input voltage. According to the input voltage, right? Do you know the reverse bias operation of the diode will give various capacitance along the reverse bias junction? Think of your reverse bias operation of a diode, right? When the diode is reverse biased, it will accumulate positive and negative charges around the junction, yes or no? As you vary the reverse bias voltage, those positive and negative charges will vary, right? In between you have dielectric and positive and negative charges vary, and that will give you various capacitances, yes or no? Right? That's what varactor diode is. The varactor diode, the output capacitance of a varactor diode varies according to the input voltage. As the input voltage varies, capacitance also will vary. That's what we require, right? So what we will do for this tank circuit, we will connect this varactor diode in reverse bias and connect the input voltage, which is your signal m of t. Done? Yes or no? Now what this capacitance? Now your total capacitance of a tank circuit is equal to this fixed capacitance plus variable capacitance, and this capacitance will vary according to what? Instantaneous value of the message signal. So when the message signal varies, the amplitude varies, capacitance also will vary. And when this capacitance varies, what will happen to the output frequency of the oscillator? Will also vary. So as per the instantaneous value of your message signal, same time instantaneous value of the frequency of oscillation also will change. Yes or no? That's what FM is. That's what FM is, nothing else. So we generated our frequency modulated wave by using varactor diode. So this circuit diagram is to generate a FM wave using varactor diode. See, this is a tank circuit. What is this? This is the tank circuit. And you see this is connected in parallel, varactor diode. This is your varactor diode. And what is connected to varactor diode? A message signal, And according to the message signal, capacitance of the varactor diode will change. In terms, it will change the capacitance of the tank circuit. And of course, you know, tank circuit will generate oscillations, right? Which is going to be your, ultimately what is going to get here? What you're going to get here is FM wave. This is called as direct method of generation of FM wave. This is called direct method. Why it's called direct method? Because directly we generate wideband frequency modulated wave for this. Directly. Right? Have understood this? Okay? So there's a drawback with this type of circuit. The drawback with this type of circuit is that, you know, these capacitors and these inductors, you know, it will create a lot of noise. This component itself will generate a lot of noise, right? So that's why these type of oscillator, this type of FM modulators are not good whenever you have highly noise environment, and this itself will generate noise. That's why this is not popularly used, but this is the way we can generate FM wave. Have you understood? Right? So now, which is an important terms to be remembered here? Tank circuit. Unless you know tank circuit, you cannot understand this. Knowing tank circuit is very, very important. And the same tank circuit have been taught in the first year electrical sciences. Yes or no? You tell me.
So the word tank circuit was not used.
Then what is used? RLC, LC circuit. It should have been told at that time. It's called tank circuit, LC circuit. You're studying LC circuit, and where it is used. If they don't say, I don't think that's going to be a proper way of teaching, whoever it is. Because oscillator is something which is going to be introduced in this communication. In this entire communication, the oscillator is going to play an important role. How do you generate 5 gigahertz waveform? 5 gigahertz, that's a entirely fantastic design of oscillator. You are going to receive 5 gigahertz signal in your mobile. All this Wi-Fi is actually, you know, transmitting in 5 gigahertz, 2.5 gigahertz. How many of you know what is the frequency? 5 gigahertz. 5 gigahertz, it won't generate as it is, right? It won't come from heaven. It has to be generated. That means there is a circuit which generates 5 gigahertz waveform. There's something called crystal oscillators. A lot of oscillator is entirely, you can make one branch out of oscillator. One program, engineering program, only on oscillators. That much theory, that much practical aspects are there in oscillators. I don't know, maybe next year in analog electronics, you may come across the oscillators. Otherwise, you will complete your engineering without knowing what is oscillators. Right? That's why I'm going to introduce the concept of oscillator, because tomorrow in interview somebody asks you what is an oscillator. What you will answer. Right? That's why I'm telling you, remember this. And in this oscillator, the tank circuit plays an important role. Fine. Okay, there is a big theory behind this oscillator, feedback circuit. This oscillator has come from the feedback circuit. Right? And feedback circuit, you know, what is the need of feedback for an amplifier? You have studied, right? To reduce? Is there only error? What is an error you get actually in an amplifier? Is there any error comes in amplifier? No. Who said? Is there an amplifier any error comes? There is no concept of error in amplifier at all. Varsha. For stability, this feedback comes always stability. Control system, you not studied what? In control system, why you have negative feedbacks? Why there is a negative feedback? Why there is a positive feedback? And what is the difference between negative feedback and positive feedback in control system? All these concepts, my dear, it is going to come in your feature, in your application. It is going to come 100%. This engineering is not something, it's Kalibali, it's a Kalivali. It's not Kalivali. Every aspects are important. That's why I said you studied control system. Right. Then why positive feedback? What will happen to positive feedback? What will happen to negative feedback? Where this positive and negative feedback applied in aerodynamic design of an aeroplane? An aeroplane is going right on the, you sit in aeroplane, aram se you go. But designing that, how much theoretical aspects have been put into that, do you know? All these control systems are going to play an important role there. Have you understood this? Okay, that's why I'm telling you it's very important. It will definitely help you if you know all these things, 100%. It is left to you. I'm giving free. Other than the course, I'm giving you some free inputs. If you want to take it. Otherwise, leave it. I'm not going to lose anything. But I want you to know all these things. Tomorrow, if you are into a good job because of answering these questions, I'll be the most happy person. In LinkedIn, you put, I am so and so working in so and so company. You'll be very happy to know that. Right? Okay? So, all these things I told you in the context of this FM, generation of FM wave. And in this, I've converted my voltage to frequency. That's all, directly. Right? My voltage variation, that is my message signal, okay? Instantaneous, every amplitude is now converting it to instantaneous frequency. Have you understood this? This is the direct way. It's called direct way of generating wideband frequency modulator. You can ask me, is there any one circuit which generates FM? No. Until you have 1,000 circuits to generate an oscillator, you have 1,000 ways of generating FM in that case. 1,000 ways of generating FM. Right? Any circuit, any oscillation generating circuits, if you vary, it will be definitely either LC or RL circuit or RLC circuit. Okay. If you vary one of the component in that, the capacitance, if you vary, okay, ultimately your frequency of oscillation will vary, right? Right? Okay. So now next circuit I will talk about UJT. What is UJT? What is BJT? What is UJT? What is FET? Right? So you can use UJT also to generate a FM wave. Right? We use a capacitance. See, when you studied FET, field effect transistor, there is something internal capacitance. How many of you know it exhibits some capacitance? Right? There is a relation you get, right? Transconductance. Have you know about this? Right? Transconductance. It will vary according to the input voltage. You have a device, you have an active device whose capacitance between its gate and the one more terminal will vary according to the input voltage. And if you make that circuit parallel to the tank circuit, RC circuit, okay, so applied voltage will vary the capacitance and capacitance will vary the frequency of oscillation. Have understood? Ultimately, tank circuit is very important, that's all. Right? If you make capacitance vary according to the instantaneous value of the message signal, oscillations will vary. You use any sort of method for that. Here we are going to make use of varactor diode. Varactor diode here behaves like a voltage to capacitance change. Right, and that capacitance definitely will generate different frequencies accordingly, you know that. But the main essence of generating various capacitance according to the applied message signal is varactor diode here. Yes or no? Who is the hero of this circuit? Varactor diode, right? The very important point in this circuit is varactor diode, right? Because varactor diode is the one which gives you different capacitance according to your instantaneous message signal. There may be other heroes also. Here it is a varactor diode. There may be other heroes. Let us see who is the other hero. Hope you are understanding, right? Let us see who is the other circuit. See, this circuit, have you understood about this circuit now? Right? Okay, a simple tank circuit. Let us see some calculations here. See, now in this circuit, you can see the varactor diode comes in parallel with the tank circuit. Okay. Now, if you see the effective circuit capacitance, see capacitance of this is equal to C naught. Okay. Now, effective capacitance is equal to the effective circuit capacitance is equal to C of t is equal to C naught minus K into M of t. Because it is a reverse bias, we are putting minus here. The effective capacitance. Okay, because you know that these capacitors are in parallel, right? When your capacitors are in parallel, you just add it. Yes or no? Right? Your basic circuit theory, right? I'm not going back once again. The effective capacitance in this circuit now is equal to C naught minus K into M of t, where K is the constant associated with the capacitance. I said proportional, right? Proportional, right? Now, suppose if M of t is equal to 0, that means your message signal is 0, right? Suppose your message signal amplitude is 0, what is the effective capacitance now? C naught, right? When the message signal is 0, can you tell me what is the frequency of this circuit, tank circuit? Fixed frequency, right? Yes or no? It's a fixed frequency, and that fixed frequency is coming from capacitance value C0, right? Okay. Now, in this case, oscillator frequency is equal to carrier frequency, yes or no? Right? Your tank circuit, listen carefully. If you understand, you will be able to understand forever. See here, first you just make your tank circuit, value of this C and L is designed in such a way that it will generate a carrier wave, right? It will generate a carrier wave. Okay, fine. Of frequency, say FC Hertz, high frequency. Right. Now what I will do, I will convert this into a FM circuit by connecting one varactor diode in parallel, where you connect your message signal M of t to that. Right? So this is also going to produce a capacitance which is equal to K into M of t. That means the capacitance of this is going to be proportional to M of t. We will put one proportionality constant K and we will equate it. Okay. Now my effective capacitance here, effective capacitance C of t is equal to C naught. This C naught minus K into M of t, because this is the reverse bias. Just apply your KVL in this. k into m of t. Now suppose your m of t is equal to 0. Can you tell me what is the frequency it is generating? Carrier frequency only. Right? Now when m of t is not equal to 0, so this is going to generate a frequency which is now proportional to the instantaneous value of the message signal. Have you understood this? Okay, that's what I have showed you here. See, when m of t is equal to 0, c of t is equal to c naught, it will generate a carrier frequency. Okay, now let us do some small analysis here. It's very simple. Did you come across with this formula? This is called design formula. Omega c is equal to 1 by root L into C naught. Right? Have you come across with this formula? Suppose if you have a RC circuit, what is the resonant frequency? F is equal to 1 by root 2 pi into RC. Yes or no? Yes or no? Forgot. I had to say everything. I don't know. See, you have this tank circuit, okay? This is C naught and this is L, okay? Now, the frequency, this will produce oscillation, no doubt about it. The frequency of oscillation, I'll write F naught or Fc is equal to, okay? Or say, or omega c equal to 1 divided by root of L into C naught. Suppose if it is omega c, what is Fc? Tell me. 1 by 2 pi root of Lc. That's the formula. Frequency by which it resonates, that means oscillates. So that's why the formula omega c is equal to 1 by root. This is actually formula for generating a carrier frequency when there is only L and C naught. Now, what happens if I connect a varactor diode? What will happen to the same? What will happen to your C naught? C naught will become C naught minus K into M of T. C naught will become, see here, the same formula will change to now, instead of generating carrier frequency, what it will generate? It will generate an instantaneous frequency. It will generate an instantaneous frequency. When this C will become C of T, which is the formula equal to C naught minus K into M of T, is it going to generate a carrier frequency, fixed carrier frequency? No, not at all, no more. It is going to generate an instantaneous frequency. And that is now once again substitute the value of C of T here. And what is C of T? C of T is 1 by C naught minus K into M of T. Now your entire formula is changed. Now can you tell me what is the instantaneous frequency depends on now? You can clearly see your instantaneous frequency omega is now depend on K into M of T. Is it not you are converting your amplitude variation to frequency variation in this? Yes. Yes or no? You are converting it. Right. So I will stop here today. Next class we'll try to do some problems. Just see a small, I will just continue from here only in my next class, okay?